All right. Where do we want to start? Is there any fun particular place we want to start on the preview? Number one. I don't know if we're going to make it if I have to explain things. Like, I could just roll through and just start writing things. I don't know if that's going to help necessarily, though. But, okay, in number one, basically there's only two things you have to even look for. What am I thinking about? I'm thinking about the number that's inside the parentheses. Okay? If it's a number greater than 1, it's growth.
Unless you have negative.
Correct. If it's less than 1, or between 0 and 1, it's going to be decay unless you see a negative exponent, which you don't see in any of these. Now, does that mean there won't be one tomorrow? Maybe, not necessarily. If you see that negative, that causes it to become an inverse. So like, for instance, if this were 3 to the negative x, you'd actually look at this like it's 1/3 to the x, and then it would be decay. But if you need to, the backup plan is always to type it in the calculator and look at it, because growth will go up to the right and decay will go down to the right. But again, it's one of those things you don't want to have to type every single one of these into the calculator. That's a different issue for a different time. Which one? 43. Okay. We definitely can do some bouncing around here. All right. I have to decide between two job offers. All right. Busy Bee Industries offered me a base salary of $60,000 with an $1,800 annual raise. That's not bad. Bugsy Corporation, huh? Yeah, I do too. Bugsy Corporation has offered you a base salary of $50,000 with an 8% annual raise. Okay, so they give you models. Which offer is best? Now, this is sort of like that quiz question we had issues with before. So here's what I would kind of think about on this one. I'd go, okay, let's see here. If I go to the y equals, and I plug each of these in, so the first one was 1,800x plus 60,000. I can actually put both of these in at the same time. So if I go to the second, I could do, okay, 50,000. It's nice of them to actually give me the form. I don't have to think about it. Make sure to get that caret in there if you're looking at your exponents. Otherwise, it's 1.08 times x. That's a totally different thing. So let's look and see. Okay. Graphically, okay, here's my table. Y1 is Busy Bee, where I'm getting the 1,800 a year. Y2 is Bugsy, where I'm getting 8%. Now, which one's better?
Bugsy.
Okay. Bugsy, okay, it won't be at first. How long is it going to take before Bugsy's offer's better?
3 or 4 years.
Okay, so yeah, that first year, bad. Okay, and that's the weird thing. It's like my first year is 0, yeah. So second year, it's still the first one, yep. So until I get to 5, which would actually be year 6, okay, so I guess it determines, how long I think I'm going to be at this job. But most of you would agree, once I get past that 6th year, it's significantly better, yowzers, okay, on the Bugsy side. So again, how you explain it, maybe you say, you know,
I typed in the calculator and it told you so.
No. Okay, maybe under 5 years, Busy Bee. Over 5 years would be Bugsy. And again, the big thing, and it was mentioned already, the percentage increase is greater over time. Oops, let me get the calculator out of the way here. But it's more than just saying, well, the calculator says so. Well, what do you mean the calculator says so? So just some sort of understanding of, you know, short term, this is better, but as the percentage has a chance to take effect, that's going to make this a whole lot better. Or you could even write down several years worth of numbers if you wanted to, but explain a little bit on what your thinking process is. And maybe some of you would even say, well, I'm not looking to probably stay at a job for longer than about 5 years, so I'm just going to take Busy Bee, and then after the 5 years, I'll go get another job. Okay, that's legit. A little odd, but legit nonetheless. But that's how we'd want to tackle that one. What else? Yes, ma'am. 33. All right. 33. We need to work on solving for x here. So again, whatever's the furthest away. So in this case, it's this 2. Now again, it's not log base 2, it's just the 2. So I can go ahead, divide each side by 2. And here's the thing again I've got to remember.
2.
I don't want to get into something that's really long-term decimally. I don't want to do any rounding at the start. Now here, 3 over 2 is just going to come out to 1.5 or 1.5. So if you want to change it to the decimal, you can. Otherwise, just leave it as 3/2. So now, 2 questions. First, what's my subbase in my log when I don't see a
10.
number? Okay, 10 with authority. So if I have log base 10 that I need to get out of there because I want x minus 44 left, I need to exponentiate. Again, log of whatever subbase this is, I'm going to turn both sides into exponents, okay? I can't just use the 10 on the left and leave the 1.5 on the right. Any algebra student knows whatever I do to one side of an equation, I have to do to both. So those will cancel. Kind of squeeze up here. Again, not yet. I don't want to do the 10 to the 1.5 yet because I've got one step left, which is to add the 44 over. Now I can type it in.
My turn.
So, when I go to type, can I get away without the parentheses? Yes.
I think I just broke your sharpener.
I'll just give it a while. The motor probably tired.
It blew up.
No, I didn't blow up. And then kind of run that way. So that's how that one would get me to my...
Oh, yes, okay. I was
Okay.
worried about that one because I didn't think it was that big of a number.
Yeah, they can be. These numbers with logarithms...
Man. Oh, I have a question. Just
Okay.
a question.
Sure.
Are you going to give these formulas on the test?
Yes.
Okay.
Whatever you see on the review, you will also get on the test.
Oh, well, then I'm done. I was just worried about that. Multiple choice.
No. Can you number
42.
42?
Oh, jeez. 42. We got money in a couple of accounts here. First account contains $3,000 and gets 3.8% annual interest. Gives us the function. Second account contains $2,600 and compounds by 5% daily. It can be modeled. How many years will it take for them to have the same balance, and which one's a better long-term investment? Okay, this is sort of like our job one that we were looking at a minute ago. So again, I will come here to my y equals, and I'll just type each of these in. So I've got 3,000 plus my 3.8% interest, and my second one, again, as long as I'm careful when I'm typing these in, I shouldn't get myself into too much of a problem here. Remember, on your exponent, though, you're going to want to put your 365x in parentheses, because otherwise it'll take it to the 365th power and then times it by some x value. and that's not what we want here. So once I make sure I got everything going good there, I can do a couple of things at once. So let me bring up the chart. Let's do the second question first. Which account is a better long-term investment?
B.
Yeah, I don't know which one's which.
The first one, y sub 1 is A, y sub 2 is B.
A. B, I mean, I can't see. This is
Yeah, because see, it takes a few years, but you start to notice as you get down into the teens here that now all of a sudden y sub 2 is getting bigger and it's starting to pull away. Okay. So when it says the better long-term investment, it would definitely be B. And again, the reason that's going to be is that you're getting the better interest rate. The other one, you started with more money, and it takes a while for that extra 1.2% to come in handy. But you're like, okay, how many years will it be for him to be the same balance? Well, I don't see the same balance anywhere. I see them pretty close in a couple areas, and that could come in handy. But, you know, how's this going to work? So, let's take a look at the graphs. And you start to be like, well, I hit the graph and nothing shows up. Let's change the window and see what happens. Let's give ourselves some extra years here. Let's go 20 years out. And my y's, if I remember, and I'm going to go back and forth here to the graph for a second, look at how large your y values are. So putting like in a y value of 10 or 20 or 50 isn't going to do me any good.
700.
Okay, I'm looking here when I go to set my, when I go to set my y value, I'm thinking like thousands here, like maybe start at, I don't know, 3,500 and maybe go up to like 6,000. Use the table to help you figure out how big you want to see your table get, okay? How big you want to see your graph get. Because now, when I go back and graph, I can see where they cross. You're like, okay, so how do I figure out where they actually cross? Well, we've done some stuff with like this before. If I use second and trace, okay?
Intersect.
Yeah, we found zeros before. We found intercepts. What I want to do now is I want to know where these two graphs cross. So if I go to intersect and hit enter, it's going to ask me this first curve, second curve question. So I notice my first one, okay, is this outer curve. So I'm just going to, okay, I know what that's there. I'll hit enter. The second curve, notice, I'm on the one below it. And it really doesn't matter where I click because the calculator is going to do all the work. Once I get there, I can click to lock it in, guess, whatever. And it tells me those two will have the same balance. The same balance will be this 4,500 number, but the years is over here. So, probably we could say here a little over 11. If you wanted to get crazy and say it'll take 11.27 years, go for it, okay? But that's how I'd find out how they're going to have the same balance. I'm just going to use intersection, which we've done. We've done intersection, we've done zeros before. But just let the calculator do it for you. Because that's not one that you're going to get an exact number just by looking at the charts.
A little over 11.
A little over 11. And then I'll probably work on putting my window back to normal here. You're like, ooh, Hardy, your arm keeps flying through there. Okay. So that's where we're at with that one. What else? What else? Asymptote is basically just the line that your graph will hug up against and never go through. There will be a lot more talk of asymptotes coming in the next section. But for now, where are we heading next?
You should just do 15. No, you should do 16.
16. Okay. All right. These guys down here, these were our nemesis on the last quiz. These are the ones where a lot of you got have oft on things. Because when I see simplify, there's two things I need to understand. Okay, 15, for instance, there's not a whole lot for me to do because I know that 5 and log base 5 are inverses and just create x. But that's the only one of those where that works. For the rest of these, I'm trying to figure out or put it into an exponent form to figure out what's going on here. So remember, when I'm putting it into exponential form, my sub-base becomes my base, my answer becomes my exponent, and my big base becomes the answer. And that's the same on all of these. So the setup, 10, base, exponent.
Do I have to find x though?
Yes, I'm just kind of working over the setup here. I have to find x. Now there's two ways I can do this. Yep, as long as I see this, okay, if you know what the answer is, well, that's fine. Just write down the x equals. If you don't know, change of base is your friend. So if I'm going to use change of base once I have it in exponent form, it's always going to be the log of my big base. It doesn't necessarily mean the bigger valued number, but the physically larger number divided by the log of my subbase. So if I don't know the answer here, I can say, okay, I'm going to do log of 27 divided by the log of 1/3. Okay, because 1/3 of the negative third is 27. And that would work for all of these. Once you get them into exponential form, I'm going to keep stressing that because I'm going to be just like I was on the quiz. If I don't see an exponential of any sort, I'm whacking you for part. You can use change of base once you get it into the exponential part. So again, here this would just be log of 1/100 divided by log of 10. Or 18 would be, and I'd hope you'd be able to figure this one out without it, but log of 5 divided by log of 5. So that's how we can use change of base to help us once we get things set up correctly. So yeah, those should be perfect now.
Do you remember 36?
36.
Just because it's per decade.
Just because what?
It's 4% per decade.
Ah, okay. Yes, having to read carefully, always a helpful thing. So on which one? Yes. So on 36, the population of a city in 1985 was 1,275,390. The population was growing at a rate of about 4% per decade.
So per year, it's like 0.00.
So predict the population of the city in 2005. Okay, here's my formula. So I've got my original amount. Since it's growing, I'm going to use the plus part. It doesn't mean I use plus and minus. Right. And here's the kicker. If I'm looking for the population in 2005, here's where the word decade comes in handy. If I was going from 85 to 2005 normally, my T would be 20 normally because it would go by years. But we're not going by years. We're going by decades, which are 10 years. So how many 10-year periods are there between 1985 and 2005? 2. So it's just 2.
I was thinking something else.
Now again, you could type that into your y equals if you want to, but I wouldn't. I'd just type in exactly what I see right there. I get my new population. So again, this is kind of getting you almost thinking in like ACT type mode. This is the type of thing ACT does to try and mess with you. You do everything right, but if you plug in 20 instead of 2, you're completely off. So be careful, read carefully. when you're doing these. What's up next? I still always wonder if this is a good thing or a bad thing. If it's like, okay, we've got a good enough understanding of things, this is going to be great, or we still haven't done a bunch of this and we really don't know what to ask. Number 11? Sure. All right, number 11. When looking at the function f of x is 100 times 5 to the negative x, Deanne thinks it must be gross since the base is greater than 1, which would be sensible. Is she correct? Well, no, she's not. Because this is the situation we talked about way at the beginning up in 1 through 4. Normally, we just look at this number and say, okay, if it's greater than 1, it's growth. But we have an exception here. We have a negative exponent. Now, it's not just the fact that it's a negative exponent that makes it decay in this case, because you can have decay with a negative exponent. What happens here is your negative exponent causes the base to have a reciprocal, to flip. So now it's 100 times 1/5 to the x is basically what it's become. Your reciprocal in there. So either use the word reciprocal, flip the base, however you want to put it. And now 1/5 would be decay. Number 11. So just like it was in the quiz, just like it when we went over it again after the quiz, if you see that negative exponent, you've got to look at that number, that base, in its reciprocal form.
I just put inverse.
Inverse is fine too. $45. What is the solution of the equation? Okay. For us to make life simple here, we need our bases to be the same, and they're not right now. So my first focus, yes, my original base here will be 4. So it'll be 4 squared. And my exponent stays here. And then 4 to what gets me to 64? 4 cubed. Once I get here, I sort of ignore my bases at this point and just look at the exponents. Remembering my exponent rules say you multiply the exponents when you go power to power. So what's that going to cause? Well, I'd have 2 to the x plus 1 equals 3 to the x minus 2. Now I'm just doing algebra 1. So I distribute my 2 and distribute my 3. Let's see. Subtract the 2x over here. Add the 6 over there. Looking like D to me. Now, to be perfectly honest, could you just plug and chug on these? Sure, but again, that's going to take time. So again, got to have a little bit, well, no, not a little bit. Got to have a firm grip on how things are working with these. But that's how we'd tackle that one. And then just to kind of back that up, on 46, since that's already been mentioned today, okay, what's the asymptote of the graph? All you need to know the asymptote of this graph, you don't even need to type it in the calculator. What's this shift represent here, this minus 2? Down 2. Because normally, when you have a growth and decay type problem like this, your asymptote normally would be y equals 0. You're like, well, why, how do you know what's y equals 0? Why would that be? Because if I actually were looking at this graphically, so I'd have 4 to the x minus 2, and I look at the graph, you notice it comes down to a certain part and then it levels off. Well, where is it leveling off? It's leveling off at y equals -2, which is a shift of down 2 from where the normal asymptote would be. Now again, can I get that by plugging it in the calculator? Sure, I can visually see right now this is kind of stopping here along where y is -2 and just kind of keep going along. But that's one of those, if I understand the shift, I can just look at that and say, oh, it was down 2, bang, just be done. What's that? So it's like, yes, except on 12, I just want to know what the shifts are and that's it. Yeah, what transformations, what shifts on number 12 is what we're looking for on that one. Other stuff, other stuff, other stuff. 49. To the back we go. What are the real solutions of x to the 5th equals 256x? Okay. Two things I would ask of you here. Number one, how many answers do you think there's going to be?
3, 5.
How do I figure out how many answers there are going to be or how many zeros there are in any polynomial?
There's a 5. That's 5.
Okay, so there should be 5 solutions. Did I do something boneheaded? Yes. I'm just looking over at the board. My answer's not right on the board because I didn't read carefully. Because it says, what are the real solutions? So let me ask you something. Look at the 4 answers that are there. Which 2 answers have non-real solutions in them? That they have imaginary solutions in them. The i's. So anything that you see that has I, and I will need to fix mine, okay, does not have the correct solutions. So here would be what I would tell you for the rest now. Anytime you're trying to look at these, you're probably going to have to do some factoring. Okay? So everything needs to be on the side where the largest exponent's going to be. Now, once I got here, could I, again, plug numbers in? Sure. Or I could say they have an x in common. And at this point, I should be able to play around and my curiosity should get the best of me. And I should say, you know what? I think 256 might be a perfect square. Let's find out. Ooh, 16. So I look at that and I say, okay, so this basically tells me it's a difference of squares. Because I square x squared to get x to the 4th. And since I just found out this is 16, it's plus and minus. And then I look and I go, ooh, one more thing. Still difference of squares. So I do that one last time. Now here's the kicker. Any part, this is going to be imaginary. You're like, well, how do you know that? The plus tells me. So this and these two are telling me where my answers are coming from. Well, if I set this equal to 0, I get 0. And if I set each of those equal to 0, I end up getting D. So I will most definitely get that fixed over on the board. 49, for those of you going on your own right now, is D. 49 is D because I'm only being asked for real solutions, just not how many solutions, period, are there. So that needs to be fixed up. Yes, ma'am?
Can you switch?
Sure.
Thanks.
So yeah, one of those little things to be careful of. One other way you might have been able to solve 49, let me just mention this quick before we hit up the next part. If factoring isn't something that would come to your head right away on this, here's my other option. If I went and graphed this, but I still have to get it in this form, so if I did x to the 5th minus 256x, and then looked at the table, notice anywhere that I see a 0 would be a solution. So I see 4 as a 0. I see 0 as a 0. I see negative 4 as a 0. So if you don't want to go to the hassle of factoring, you can put it in, again, once all the terms are together on one side, into the graphing part and just look for zeros. Just something to put out there, just something to consider. Where else do we need to head? Any requests? Otherwise, maybe I can come up with something here. Ooh, already gets to pick. All right, let's see. What haven't we been up to? Okay, 25, no canceling. We're just attempting to condense the expression. So just a reminder again. Subtraction will become divide. Addition will become multiplication. And those would be the things that I would do actually second here. Because what I'm going to do first in this section is any coefficients I see are going to become exponents. So like for instance on 25, I see there's a coefficient here with my 7. That's going to swing back up here to the top and become x to the 7th. So then I take a peek and I'm like, well, I don't see any addition, but I see subtraction, which tells me that part gets divided. So I'd have the natural log of x to the 7th over y. And that would be my condensed form. And when you go to do expand in the ones just above, it's just the opposite of what you're seeing here. So divide would become subtract, multiply would become add, exponents would become coefficients. Just like when we were going through those sections. 49 and 50. All right, let's see what we got here. So 49 we already did. Yeah. So now 50. Which of the following is a factorization of? Oh yeah, one of our favorite things of all time. Difference of cubes. Okay, what do I need to cube, notice the 3, to get each of these terms back?
X and 3.
X and 3. So when I go to do this is kind of a review of some stuff we've done before. I'm going to do x minus 3 because the minus is in here, of course. Now again, we'll use some strategy as we're doing this. The ones that are x plus 3, okay, they're not the right answer. So now I'm down to 50-50. So I notice the only thing that's different between A and D is this sign. I don't even really have to go through and do all the factoring from here. What I have to remember is these are always going to be opposites when I'm doing whether it's a sum or difference of cubes. So at that point, I can go to A before I even do anything. Now, if you want to remember kind of the understanding of where it's coming from, once I get here, I square my first term. I change the sign, so these are always opposites. I multiply my two terms together, not with the minus, just these two, which would be 3x. And then I square my last term. So 3 squared is 9. That's where this is coming from. But like I said, if you can remember that it has to be minus in the middle and that these always have to be opposites, I really don't have to factor anything. So there's lots of ways to save yourself some time and effort if you just take a second to think about it. Any others? Anything else causing issues? Am I safe to click end? Apologies to those of you watching it later with the long delays.